Hello everyone. Through this video, we are going to discuss some additional questions on transpose of a matrix. In my previous video, I had discussed two more questions on the same part. So here in this question, the first question goes here. The first question is, show that a matrix which is both symmetric and skew symmetric is a zero matrix. And for that, we have to make an assumption. Let capital A is equal to, this is matrix representation, be a matrix which is both symmetric and skew symmetric. We consider this like this only, both symmetric and skew symmetric. Since now let us come to the first part, symmetric matrix. Since A is symmetric, so what can we write? By definition of symmetric matrix, actually when a matrix A is symmetric, we get what? A dash is equal to A. That means transpose of the matrix capital A is equal to the matrix itself. So in this case, we can conclude that AJI is equal to AIJ for all possible values of I and J. That's what I'm going to write here. Since matrix A is symmetric, this will imply, let us write matrix here. This will imply what? A dash is equal to A. That again implies AJI is equal to AIJ. So let us consider, let us take this reversely. AIJ is equal to AJI. So here in this case, I have to add one more thing. For all values of I and J. This is actually in accordance with the definition of symmetric matrix. Okay, let us mark this as equation 1. Next again, when we come to the skew symmetric part, if I write here, since we get A is skew symmetric, so in that case again, when A is skew symmetric, we get what? AJI is again equal to minus AIJ. Actually before that I should write A dash is equal to minus A. Actually this is the basic thing. This is the condition by what skew symmetric property becomes clear. So here in this case, since there is negative sign on the right hand side, therefore AJI is equal to minus AIJ for all possible values of I and J. Further, we can write here AIJ. If I write it reversely, it will be AIJ is equal to minus AJI. So this can be marked as equation 2. Now adding 1 and 2, when we add equations 1 and equation 2, we get the result. From equation 1, it is clear that AIJ is equal to AJI. So keeping the right hand sides of both the equations on one side together, we get AIJ plus again AIJ. This side and this side we are keeping together, which is equal to, I can write here AJI, and on this part we are having minus AJI. So both these two things are getting cancelled, and I get back twice AIJ is equal to 0, and ultimately in the last step, we after cancellation, if we remove if we remove 2 from both the sides, it will be, dividing both the sides by 2, I get Aij is equal to 0. Actually, this can imply that capital A is a zero matrix. Zero matrix for all possible values of I and j. This is true for all possible values of I and j. So this is what we had to prove, hence shown. So this is the answer of this question. This is another additional important question. Question number 2 says that show that A dash A and A dash are both symmetric matrices for any matrix capital A. Now in this case, I am going to consider A dash A as any matrix capital X and A dash another matrix capital Y. Let us check whether both are symmetric or not. So in this case, if I assume let capital X is equal to A dash A. This is the first matrix I am taking. To examine the symmetric properties of this matrix, what I have to do, I have to find out transpose of the matrix capital X. For that, on both the sides, I am finding out the transpose A dash A on the right hand side whole transpose. That will imply what? X dash is equal to, we know one thing, if I by the property of transpose, this is the property actually, A B whole dash is equal to B dash A dash. So here actually when we find out transpose or product of any two matrices, that gives us back the product of transpose of their of the individual matrices taken in the opposite order. So in this case we can write A first. If we follow this format, this A matrix will come first, means A dash followed by A dash whole dash. So that will further imply X dash is equal to A dash. Again we know one thing, that A dash whole dash, this is by property of transpose of matrices. So this A dash whole dash will give us back matrix A. So I get here A dash is A dash whole dash as A. So I get the result, X dash is equal to, again if I observe, these two things are same. For X, whatever value we assumed earlier, the same value I am getting for X dash also. So here in this case, in place of this matrix, I can put the value X. Therefore it is clear that, hence clearly X equals to A dash A is a symmetric matrix. Coming to the next part, for the second part, I shall have to assume Y as A dash in the second case. So here in this case, I am going to assume, so let us consider, again let Y is equal to A dash. Again in this case we have to check, we have to observe the same property exists or not. So in this case I am going to consider again the transpose on both the sides, A dash whole dash. So finding out transpose on both the sides, actually to show that Y is symmetric, we have to find that Y dash is equal to Y. Let us check whether it happens here or not. Y dash is equal to, actually by product rule of transpose of matrices, this will be getting reversed. The order of this two matrices, transposes of these two matrices will be reversed. So here in this case I get A dash whole dash into A dash. So this matrix is found in the first position, while followed by the transpose of this matrix in the second place. So I get here, after this, Y dash is equal to A dash. it can be observed that whatever result I got here for, I assumed for y, the same value I'm getting for y dash also. So in the next step I can write y dash is equal to y. So this will imply what? This implies y is equal to a dash is a symmetric matrix. Symmetric matrix. So what conclusion can we draw here? As the last line we can write, the conclusion we can write here as therefore a dash a and a dash are both symmetric matrices for any matrix capital A. So these are the two additional questions discussed here. In my next video, some more questions on transpose of matrices and the other parts of matrices we are going to discuss. Thank you.